Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 23, 2025, about 3 days ago. This paper introduces ThinkARM, a scalable way to break a model's reasoning trace into functional episodes like read, analyze, explore, implement, and verify, which exposes a surprisingly consistent three-phase reasoning pattern and shows that exploration acts like a key branching point tied to correctness. The paper is titled Schoenfeld's Anatomy of Mathematical Reasoning by Language Models, and as we will see later, the implications for diagnosing and shaping model reasoning are quite significant. Also, the authors shared a companion GitHub repo for ThinkARM. You will find the full dataset of model responses and episode annotations, including Goldhuman labels, plus the Python code to automatically label reasoning episodes and reproduce key analyses like temporal dynamics, word clouds, diagnostic studies, and correctness evaluation with runnable scripts and setup instructions. Figure 1 shows what ThinkARM means in practice by turning a long chain of thought into labeled reasoning episodes. The left panel gives the math question and the legend of 8 categories, which are functional stages like read, plan, and verify rather than raw tokens. The right panel highlights each sentence in a model response with a color tag, so you can track when it shifts from understanding to execution and then checking. Table 1 matters because it picks which automatic labeler the authors trust to tag episodes at scale. The table reports accuracy and kappa, where kappa measures agreement with humans after correcting for chance. The overall columns show that GPT-5 has the strongest human agreement, so it becomes the annotation engine for the full dataset. The reasoning and non-reasoning blocks show that this choice holds across both response types, not just one corner case. Figure 2 means that the 8 ThinkARM episodes are not just labels, because each one comes with its own distinctive vocabulary. The full figure lays out a grid of word clouds, one per episode, where bigger words appear more often in that type of sentence. The read and analyze clouds lean on problem setup and math structure, while implement shifts toward procedural words like compute. The verify and monitor clouds feature self-checking language, which supports separating evaluation from execution in practice. Figure 3 shows that reasoning has a repeatable rhythm once you align every response onto a 0 to 100% progress axis, which just means rescaling different length solutions onto the same timeline. The read panel drops fast, and analyze plus plan taper more slowly, so scaffolding fades but does not vanish immediately. Implement forms a mid-trace hump. Verify climbs toward the end, monitor dips then rises, and answer spikes at the finish. Table 2 shows that models do not just differ in how long they talk, because they also differ in how they spend their token budget across episodes. The full table lists episode percentages and token counts, so darker cells mean more budget for that reasoning behavior in practice. The top block of open trace reasoning models spreads tokens across analyze, explore, and verify, while the instruction following block concentrates on implement. The distilled models stay close to the DeepSeek R1 allocation pattern. Table 4 shows which episode behaviors most reliably separate correct from incorrect solutions, using a sparse model called lasso logistic regression, which keeps only the strongest signals. The left half lists positive contributors, where explore to monitor and explore to analyze stand out, so successful traces turn uncertainty into self-checking and renewed understanding. The right half lists negative contributors, where a high explore ratio is the strongest risk signal. The table also flags disruptive loops like monitor to read as harmful, because they look like backtracking without progress. Alright, 2 takeaways stand out. First, episode-level labeling makes reasoning traces legible, revealing a stable 3-phase rhythm from setup to execution to checking and final answer. Second, exploration is a real pivot point, where productive traces turn uncertainty into reanalysis and monitoring. The broader implication is that this kind of lens can help diagnose and shape reasoning, not just score outputs. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.